Homework 8, number 5. So in this problem, you're asked to write a loop that creates the following 4x4 matrix. 1, 2, 3, 4 in the first row, 1 squared, 2 squared, 3 squared, 4 squared in the second row, then cubed in the third row, and to the power 4 in the fourth row. Okay, let's go to MATLAB and try to see how we're going to approach this. So I'm going to start a new script, and basically I want to, let's add a comment with the objective. Create a matrix with the following elements: 1, 2, 3, 4, 1 squared, 2 squared, 3 squared, 4 squared, then cubed, the third one, so it'll be cubed, 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 and finally to the 4, right? 4, 4. So if I just copy this into my command window just to see what it would look like. This is the matrix I'm looking for, right? 1, 2, 3, 4, 1, 4, 9, 16, all the way to the end. Okay, so how do we do it? What's the strategy to do this? Let's try and come up with a game plan to try and run this. So first of all, we have 4 rows and 4 columns, right? So I have 4 rows and 4 columns. And in every row, I'm gonna have 1, 2, 3, 4. And as the column number increases, I'm gonna have the power increase as well to the maximum of power 4. So it makes some sense to start with a for loop. So let's start with a for loop and run it from I to 4 and just start developing it from there. So I'm gonna say from I, which is my index, over my values, which is 1 to 4. I'm gonna create a matrix A, and before the loop, let's define A to be equal to 0. And let's add CLC and clear, just good practice to clear out the screen and the memory. Okay, so for I equals 1 to 4, I want A of so I want A of so when I equals 1, so I want the row or the first row to insert 1 to 4, right? And again, it's always important to remember that let's add a comment here. In a matrix, the notation is row first, then column, right? So so if I say A of I, for example, A of I, comma 1, this means that I have, this is the first element in the first column, right? So this is row I in column 1. But in our case, I want to have 4 rows and 4 columns. So let's try and create a 4x4 matrix just using a for loop. So I'm going to use a second counter for, let's call it k equals 1 to 4. And the idea of this second counter is to create a 4, or basically an I by k matrix, right? And let's just test it. So let's just say I comma k, and let's just put 1s in it. And I'm gonna end the inner for loop, I'm gonna end the outer for loop. And in the situation when you have 2 for loops inside each other, this is called a nested loop situation, right? So when you have 2 for loops, or 2 loops actually inside each other, 2 loops inside each other, this is called a nested loop, right? So let's try and run it and see what we're gonna get out of this. Okay, let me just display A, capital A, just be careful. I'm gonna run it, it'll ask me to save it. I'm gonna save it before going back. So again, save it to a location where you can find it, homework 8, number 5. And if I run this loop here, I'm gonna get a 4x4 matrix, right? So the idea is that, let me move this comment here. So the idea is that because when calling a matrix element and you're using I comma k, the first number denotes the row, the second number denotes the column. So that's why I need to, because I have 2 dimensions, I'm running 2 loops, right? So the first outer loop will be the first number, which is the row number, and then the second inner loop will be the second number, which is the column number. And if we run through this loop, so if I try to run through this loop on paper to try and see what it does, so initially A equals 0. So first iteration of the outer loop, so I have the outer loop, which is basically the I loop. For the first iteration of the I loop, I equals 1, and then I'm going to go into the inner loop, which is the K loop in this case, right? K loop. I'll have the first iteration of the K loop, right? First iteration of the K loop. So K is equal to 1. So basically A of 1 comma 1 is equal to 1, right? And then you have the second iteration of the K loop or of the inner loop. K equals 2. So A 1 comma 2 is equal to 1, etc., etc. And then K becomes 3, A1 3, A1 4. And then you exit the K loop and you restart the second iteration of the I loop. So now I becomes 2. And again, K is equal to 1. So in this case, you have A2 1, A2 2, etc. all the way to the end. Okay. So if I rewrite matrix A just using its elements, so I'm going to have, and again, we said it's row column, so I have A1 2, A1, sorry, this will be A1 1. First element is A1 1, second element is A1 2, third element is A1 3, fourth element is A1 4. Then I'm going to have second row 2 1, A2 2, A2 3, A2 4. My third row will be A3 1, A3 2, and finally, right? So these are my array elements, and I want to basically insert these numbers into this configuration, right? So I want to have, so in A11 I want to have 1, in A12 I want to have 2, in A13 I want to have 3, in A14 I want to have 4. In A21 I want to have 1 squared, 2 squared, 3 squared, 4 squared, and then here I want to have 1 cubed, 2 cubed, 3 cubed, 4 cubed, then 1 to the 4, 2 to the 4, 3 to the 4, 4 to the 4, right? So there seems to be a trend here, right, developing, especially if we take a look at them just next to each other, maybe this will help. So if I put my comments here, so this is what you want, really. Right, so A11 has to be 1, A12 has to be 2, A13 3, A14 4, A21 1 squared, A22 2 squared, A41 1 to the 4. And you can see there's a pattern here, right? So the number in this position, for example, is equal to 1 to the power 2, the number in this position is equal to 1 to the power 4. The number in this position is equal to 2 to the power 4. So technically I want a to the I comma k, or that's I comma k, to be equal to k to the power I, right? Because if you think about it, in this element, for example, a of 4 comma 2 should be equal to 2 to the power 4. So this is the line that will really do this operation for me. So let's go back to the loop and just insert this line here. So I have k to the power I, and let's run it to see if we're going to get the desired result. So if you run this loop, this is what you get. Again, you're going to get the result you're looking for, which is first loop first row 1 2 3 4, second row 1 2 3 4 squared, third row cubed, fourth row to the power 4. And what we did is we just wrote down the matrix with all the elements we want. So I want the matrix to have this 1 2 3 4, 1 squared, 2 squared, 1 cubed, 2 cubed, 1 to the 4, 2 to the power 4, etc. And then I wrote their corresponding location in the matrix A. So A11, A12, A13, and then we determine the pattern here. So in this case, if I look at 1 squared, it's in location 2 to the power 1, so it's the column number to the power of the row number, right? So if I'm using I and k to denote my row and column, this will be the column number, which is k, to the power of the row number, which is I. So try to think about it, try and understand the approach here, the logic here, and try to get your head around it. If it's not clear, come and ask me during the office hours.